mainly focused on how to make the thing how to add computational intelligence to a thing, right or not? So in that sense, we have used Arduino Uno. So in Arduino Uno, we have just interfaced a temperature sensor. Okay. So we want to monitor a temperature, like we have interfaced a temperature sensor, and we have seen some aspects of that, right or not? So today we need to consolidate this issue, okay, of adding a computational intelligence to a device, okay, computational intelligence to a thing. So this is the overall overall architecture we are talking about in the thing in the last class, right? So today we need to see these aspects, right? So these aspects, okay. So that you'll have some consolidated content so for whatever you understood regarding the IoT, okay. So we focus on sensors, okay, and we focus on, okay, local processing, okay. Generally this local processing, okay, local storage, so this thing we generally call okay, we call this as embedded system, okay. So where we have sensors, okay, where we have actuators, where we have some local processing is done, and where we have some local storage. So all these issues we commonly we call it as embedded system. So that is our main today's agenda, okay, today's agenda. So before going actually to the presentation, okay, let me explain you, okay. So what is meant by actuator and sensor, okay. So what is meant by sensor and actuator, okay. So we try to understand this by simple, okay, simple control system, okay, concept, okay. So for example, okay, I have a plant, we have a plant, okay. Plant is nothing but some industrial plant, for example, okay, some industrial plant, okay. So maybe some industrial something, right, okay, something, okay. So in this plant, what I need to do, I need to maintain a temperature of this plant to 500 degrees, okay. I need to maintain the plant temperature, maybe some turbine, okay, maybe some boiler, whatever it may be, some boiler, okay. So in this boiler, I need to do some chemical reactions, okay, such that I need to maintain a temperature to 500 degrees, okay. So you think like that now, okay. Now what is this, how we do this maintain? So definitely boiler means there is some heater will be there. So that heater will be heating it, and that inside chemical will become 500 degrees. But how we know that exactly? We can't touch, right? We can't touch that and see, right? It's 500 degrees centigrade. So how to automate this? How to automate such that the temperature will be 500 degrees? So how they do that is, so first of all, they want to know what is the exact temperature of the plant, okay. So what is the exact temperature of the plant, okay. So for that, what they do, they deploy sensors, okay. So they deploy sensors in the plant, okay. So using, for example, in this case we are interested in temperature, okay. So they measure the temperature, okay. So what is the exact temperature? It may not be 500, right? It may be less than 500 or more than 500, whatever it may be, okay. But our objective is to maintain a temperature as 500 degrees, right? So what they do, they deploy sensors, okay, such that they measure the temperature of the, what is the exact temperature of the boiler, okay, of the plant where boiler is located. So they deploy sensors. Now after knowing this, okay, after knowing this exact information, okay, what they do, they use some comparator, okay. This is something called comparator, okay. It just compares, okay. For this comparator, what they do, they give the desired value, okay. They give the desired value, okay. What is the desired value here? So desired value is temperature should be maintained at 500 degrees, okay. And they get the actual value, okay. They get the actual value, okay. So okay, so actual value may not be, okay, may not be equal to 500, right? It may be less than 500, right? Initially, definitely, right? So what they do, they have the difference, okay. So they have the difference between this, what is the actual value, okay. This is the actual value, okay. So this is the sensor input, okay. This is a sensor output, this is the actual value. Now they compare this actual value and the desired value. So based on that, they generate an error, okay. We'll get an error, definitely, right? So now what they do, now if I want to rectify this error, what I need to take care? Suppose the temperature is less than so let me suppose temperature we have started initially, right? Initially we try to boil, right? Temperature will be definitely less than 500 degrees centigrade. So it is reaching the 500 degrees centigrade, right or not? So if it is not 500 degrees centigrade, if it is less than 500 degrees centigrade, we will get error. In such a scenario, what we need to do? Okay, we need to turn on the heater. Okay, so for example, we need to turn on the heater, heating whatever that heating mechanism we are utilizing, that heater we need to turn on. Okay, we need to turn on that heater. Okay, turn on, okay, some heating mechanism, whatever we are using, right? So this turning on, maybe we can use some relay switch here. Okay, some relay switch to turn on that heating mechanism, right or not? So definitely this, if we turn on this heater, definitely that plant temperature will vary, will keep on increasing, right or not? So that's what. So what we do, so this is what the control system. Okay, so if we want to maintain a temperature of 500 degrees centigrade, we are actually sensing that 500 degrees centigrade. If it is not equal to 500 degrees centigrade, so we'll get an error. Okay, so if we get an error, it will turn on this heating, okay, heater, so that heater will turn on, so that temperature will rise to 500. Okay, so if the actual value is equal to the desired value, like if it is a 500 degrees centigrade, what happens? The error will be 0. So whenever the error will be 0, this okay, this mechanism needs to be off. Okay, this mechanism will be off. So again the plant will be 500 degrees. Again after some time it may reduce. Okay, after some time it may reduce to some 450 like that. Okay, so after if it reduces, again it will generate an error, again it will turn on the heater. Okay, so like that you might have seen in this mechanism in the iron box, right? In iron box also same thing. So if you want to maintain some iron box, some temperature, right, you adjust, right? So you will be seen that okay, constantly that heater will be turning on, turning off. You might have noticed in the iron box. So same thing here. So what is this? So this block where we are turning on the heater, so this is called actuator. Okay, so where the mechanism where we are sensing the actual temperature of the plant, so this is called the sensor. Okay, so you know, right, what is a sensor now? Okay, what is a sensor basically? So sensor, definitely sensor, what it is, a transducer. Actuator is also a transducer. Okay, so basically sensor, it is converting, okay, temperature, one form of energy to another form. It is sensing the temperature. Okay, so what actuator is doing? Actuator is here it is turning on that. Okay, we are turning on the relay. It is okay, transform, it is turning on the relay, right or not? So this is the basic understanding behind what is sensor and what is actuator, right or not? So definitely in the third year, okay, third year or maybe second year, second semester, you will be studying one subject called control systems. Okay, I don't know, you will be studying one subject called control systems. Okay, so in control system subject, so this is what, okay, this is what you model as closed loop control system. Okay, so closed loop control system. Okay, this is what closed loop control system. So where you model this thing with a transfer function. Okay, you model everything, all these things, okay, with a transfer function. Maybe I think you might have studied, I don't know whether you are studying this subject or not in this semester. So you model this with a transfer function, right? After modeling this transfer function, you analyze all this, right? You will be analyzing this with the help of a transfer function. You will mathematically model this such a closed loop control system, and there you study, right? Okay, based on this you perform different analysis. Okay, you find the transient response, you find the steady state response, all these things, transient analysis, steady state analysis. You convert this into frequency domain and perform frequency domain analysis. So all these things you do, time domain analysis, whatever it may be. So this is our intention here is we need to understand what is sensor and what is the actuator. So this is the basic understanding. Okay, so with this basic understanding, we'll move forward in our presentation. Okay, so these are the different sensors. Okay, this is some statistics they have given. These are the different kinds of sensors we are using right nowadays. For example, it's a smart city. Okay, we may think of this picture as a smart city. Okay, so in a smart city, you will be having all these things like motion detection sensor. Okay, for example, you may utilize this motion detection sensor. For example, some people violating the traffic signals. Okay, so see here, this is deployed in the traffic. Okay, this is deployed in the traffic. Okay, So based on that, you may have some system like someone violating this okay, traffic rules, like that you may estimate. Okay, so like smoke sensors, okay, you may deploy the smoke sensors to detect the any tragedies, like any fire accidents, like that. Okay, you may deploy the chemical sensors, for example, to measure the pollution. Okay, to have a pollution, for example, you want to know, right, where the pollution is happening in a smart city. Okay, more pollution, for that you can deploy chemical sensors. Okay, like gas detection, you may deploy gas detection. Okay, any gas leakage is there in any industrial process, like that. You may deploy temperature sensor to detect, to have a temperature, like temperature sensor you have many numerous applications. Okay, you have IR sensor, okay, to measure the distance. Okay, like proximity sensor. Okay, accelerometer sensor, so different to measure the acceleration. Okay, similarly many sensors like gyroscope. Okay, so this is the basic idea, right? You might have seen such diagrams whenever you see any IoT course. These are all sensors. Okay, so these are all sensors. Okay, so the thing is, okay, Babu. So with this, see, these are the different sensors. Okay, temperature sensor, proximity sensor. Okay, pressure sensor, water quality sensor, chemical sensor, gas sensor, smoke sensor, IR sensor, level sensor, image, motion detection, accelerometer, gyroscope, humidity, optical. Okay, so whatever may be the sensor, okay, we need to generalize this, generalize these things, right? So what is a sensor? Basically, what is the input to a sensor and what is the output of a sensor? Why we need to do that output after getting output from a sensor? What we need to do? So all these things we are going to discuss in the present, in the coming slides. Okay. So basic motivation behind learning the sensors is, right, so you find the sensors in every electronic products, right or not? Even if you see washing machine, okay, for doing all the automation in the washing machine, at least you might be having water level sensor, okay, in a washing machine. Okay, water level sensor to detect the water. Okay, water level, maybe you might be having something called to turn on the motor, you will be having some actuator. Okay, so like that, many sensors are actuators located in all these electronic smart products. So even this is driving the technology revolution called IoT. Okay, so people call IoT without sensors, it's not possible. Okay, so the data generators for IoT is are sensors. Okay, so okay, Babu. So this is something which human have 5 senses. Okay, so you all know this. Okay, you see this, some of the examples. Okay, uh, like in case of a smartphone. Okay, so in case of a smartphone, you have process sensors. Okay, so you have a temperature. Okay, why this temperature, what this temperature sensor is doing in your phone? For example, you keep your phone in a hot sun. Okay, you expose your mobile phone to a hot sun. Okay, to a huge temperature. Okay, what happens? Suppose if temperature rises some value, some abnormal value, your phone will automatically shut down. Why this happens? So inside your phone there will be some temperature sensor, some thermistor will be there. So that sensor will be detecting the temperature of the surrounding. If the temperature exceeds that particular value, it will automatically shut down. Okay, so it's like that. Like we have a position sensors like GPS, proximity, like motion sensors, gyroscopes to detect the angular position. So accelerometer, okay, to detect the gesture control. Okay, ergomatic sensors like capacitive touch screen. Okay, these are all ergomatic sensors. And finally, electrical battery life. So you will have some electrical sensor in your mobile phone, like it will display the battery life, right? So how it will display? Based on the sensing mechanism. So internal to the battery, there will be some sensing mechanism will be there. The sensing mechanism will detect the presence of the battery, how much battery is remaining. Okay, so all these are the common examples of sensor which is located in your smartphones. Like you can see these modern automobiles, right? So previously the automobiles are electromechanical control. Now your automobiles are these sensor based controls. So all these different sensors like okay, temperature, Okay, so I think so different sensors are there in your automobiles, right or not? So for example, the best example I can give this accelerometer airbag sensor. So what is happening? So if your car is driving, right, the car is driving, some accident happens, okay, so there will be some internal system in the car, it will detect the accident, okay, based on the detection of accident it will open the airbag. Okay, I think you can feel this. So airbag will be opened automatically whenever your car undergoes accident, right? So this definitely such a system is designed with the help of sensor and actuator. Okay, so like you take a normal elevator, so elevator also, to in order to elevator to function, okay, there will be different sensors are there. Okay, so different, for example, your elevator have to stop, you have to detect the top floor. Okay, so top, it will not strike the go and strike the top wall, right? So why whenever it approaches the top wall it will slow down, right or not? So how it slow downs, right, based on some sensor. So this top wall is detected. Like if you press the fourth, okay, fourth, you want to go to the fourth floor, automatically it will stop in the fourth floor exactly, right or not? So definitely there will be some level sensor. Suppose if the sensor is not working properly, you might have seen sometimes, so the lift may go up or come down since this level sensor is not working properly, I don't know, like that. For example, you might have seen these doors are there in our D block, automatically this will open, right? So whenever you come across, you just keep the hand, right? So it will detect your hand and it will open again, right or not? So all these such a systems are based on the sensors, right or not? So this is the basic feel of sensors in your daily life, right? Like that you can use sensors. For example, you have a bridge, okay, you have a bridge, so yeah, you want to monitor the health of a bridge, so you can deploy the sensors and you can collect the data. Okay, so based on that data you can monitor the health of a bridge. Okay, like that, predictive diagnostics. Okay, you can have a sensors inside this truck or inside your car. Okay, so you can collect the data from that sensors, you can predict. Okay, even before your car get damaged, you can predict what part is going to damage. Okay, when your car requires a service, all these things you can predict. Okay, whether your car requires engine oil to be replaced. Okay, all these things you can get notifications to your mobile. Okay, if you combine such a sensors with IoT. Okay, so okay, like this, these are the different sensors for predictive maintenance. Okay, strain gauge, okay, LVDT, capacitive sensors, okay, airbag sensors. Okay, um, another best you can relate the, okay, sensors with the humanoid robot. Okay, so robotic automation, definitely if you want to automate the robot. Okay, so it has different sensors, so with the help of sensors only it is able to operate, take decisions, right? It able to predict that environment. Okay, so whatever the sensors we have, or so based on the sensors only, right? So these are the something you can relate what is the sensors. Okay, like this is a electronic nose example, I think you can see here. So what actually, so you know that this is a coffee. Okay, if you, how you know that? So based on your, you smell this, right? You smell this, based on that it will, that signals goes to the brain. So based on some neurons, okay, based on some neurons you come to know that this is the order of the coffee. Okay, how you know first time, how you know it's the order of a coffee? Someone have told after you born. Okay, someone have told, okay, maybe your mother or father told. If you smell it, if you might have asked your father or mother, like, what is this smell? So they told that, okay, it's a coffee. So you remember, you map. Okay, whenever you get a similar smell, you always remember that it's a coffee. So same thing you want to do artificially. Okay, we want to develop certain brain, artificial brain for this. Okay, so definitely for that also we can have a sensors. Okay, we can have a sensors, using sensors we can acquire that signals. Okay, so the signals, from that signals we can come up, we can process the signals. Okay, and we can come up some valid information, valid features. Okay, whatever it may be. So these valid features you may apply to the neural network. and you can tell, okay, whether it is a coffee smell or not. Okay, this is what, right? Machine learning, deep learning. Okay, so okay, like that. Okay, this is a precision agriculture, right? So precision agriculture, see here, in this precision agriculture means you want to yield the crop. Okay, you want to get a more yield, like okay, proper crop. Okay, for that what you can do is, this is a field, for example. In this field you can deploy the different wireless sensors. Okay, and you form a network. Okay, you form all the sensors, you can deploy different sensors and you can form a network of sensors. Okay, now what you can do with these sensors, you can have a precision, right? Like you can have a decision making, like whether the water is required for this. Okay, whether anything, any fertilizer is required, or any plant is getting damaged. Like all these things, you may get notifications. You may automate these things, no need to go and manually monitor. Okay, each and every time. Like that you can have a cows. Okay, you can connect, you can have a network of cows. What you can do, suppose any cows has a ill health, or okay, right, you don't know, right? You'll be not monitoring, right? Cows, right? Maybe they die because of some ill health. So if you can get some proper treatment to them, they would have survived. Or if any cow is pregnant, you can give her a proper treatment, right? In such a scenario, you can have a network of cows. Like that you can have a drones, you can operate automatically these drones, maybe to have a fertilizer. So all such systems. Okay, you may have agri boards, so different agri boards operating automatically without any manual, of course. Here the human is there, just sitting inside behind the computer. Okay, and operating all these things. Okay, like this nowadays they are investing more, right? Like this they are coming systems. Okay, so this is what, okay, this is what another system. For example, if any accident happens, okay, for example, you see the advantage. If any accident happens, okay, so this accident can be automatically, okay, detected by the car. Okay, accident. So these cars will send a signal, okay, to a nearest ambulance station, or nearest hospital or ambulance station. Okay, so ambulance will get a location. So ambulance automatically goes to the spot, take the patients. Okay, they may take the patients. After taking the patients, what they can do is, inside the ambulance they can have some first aid kind of thing, like they can monitor all the first aid, what is the damage happened to that patients. So that thing, entire thing they can do. So also this, the doctors present in the hospital can monitor their status. So based on the coming, okay, so based on since, right, so many such situation happens, right? So even the patient going there again, he have to take all the basic tests, so then he may die, right? Like that many situations are happening, right? So before the patient reaches the hospital, the doctor can come up with a treatment decision. So what to do for him, whether we need to do surgery or whether we need to do some, okay, so that decision making, so that they can do in the traversal, while patient is traveling to the, before coming to the hospital. So directly they can take to that and they treat, right? There is a chances of okay, person saving their life. So these all such systems can be done with the help of IoT only. Okay, see whatever it may be, like you may see right here, you can monitor all the okay, parameters of a human body, okay, with the help of sensors again. Okay, so whatever it may be, all these examples you can relate what is the sensors, what are the sensors and actuators. Okay, so with this basic understanding, okay, also the smart grid. Okay, so now the normal electric, whatever the electricity infrastructure we have. Okay, so with the help of IoT, they can have the smart grid. Okay, so you can optimistically utilize the power. Okay, this is something high level concept, smart grid and electrical vehicle charging, right? So this is electrical vehicle charging. These are the many advanced applications which are possible with the help of sensors. Okay, with the help of sensors, actuators and IoT. Okay, so okay, Babu. So with this, basically we can see the basic properties. Okay, so which we can detect with the help of sensors. Okay, for example, you may have a process sensors. Okay, so process sensors are used in some petrochemical, pharmaceutical, semiconductor industries. Okay, so I'm not even we are so just see this. We are not defining any what is the definition of sensor, what is the definition of actuator. So just to go through it. Okay, so we'll define in a short time. Okay, before that, just go through this slide. Okay, we have a flow. Okay, level, temperature, pressure, vacuum. So these are all the different parameters. Okay, physical parameters. Okay, so physical or environmental parameters. Okay, physical or environmental parameters. Okay, which we are interested in, right or not? So for example, what is flow or level? Okay, what is a flow or level? So for example, you have a tank. Okay, you have a tank, water tank is there. So this water tank, what it have to do, it have to take a decision, like if the water tank automatically fills, it will become full automatically. What it needs to turn off the motor. Okay, for that you can deploy some water level sensor here. Okay, so this water level sensor, it detects the water level. Whenever it is full, it can automatically turn off that with the help of an actuator. It can turn off that motor. Okay, like that, right? Many applications you can have. So position sensors. Okay, so position sensors like GPS, this radar, sonar, all these sensors. Okay, like electrical sensors. Okay, you may find in labs. Like that, you have motion sensors. Okay, gyroscope, accelerometer, speedometer, ergomatic sensors like touch, optical, acoustic. So chemical sensors. Okay, so different chemical sensors for protect us from fire and toxic vapor hazards. Okay, so these are the different field, okay, of what are sensors and what we can do. Okay, Babu. So with this, we come to the technical part of the what is sensor and what is actuator. Okay, so before even the terminology what is sensor and what is actuator, we have a term called transducer. Okay, so what is transducer? A transducer converts, okay, okay, one form of energy, okay, one form of energy to another form. Okay, to another form. Okay, so for example, you want to fill a air in your scooter or in your car. What the user what he keeps some meter, right? Pressure meter. Okay, he keeps some pressure meter. You know what is it? That is called Bourdon tube. Okay, so he keeps some pressure meter and checks the pressure inside the tire, right or not? So based on that only he fills the air inside the tire. Okay, so what in such a scenario, you know what it is doing, that thing, it is converting the pressure, whatever the pressure is there inside the tire, it is converting that pressure to the displacement. Okay, it is converting that pressure to the displacement. Okay, so what it is doing, so this I am calling it as a transducer. Okay, so what this transducer is doing, it is converting the one form of energy, okay, pressure, to the displacement, which is another form of energy. Okay, so for example, like that, right? For example, you may also convert, for example, if you convert you may convert this pressure to displacement to another quantity. Like if you put LVDT, for example, LVDT is one circuit, electrical circuit. It is called linear variable. Okay, linear variable differential transformer. Okay, differential transformer. Okay, this is one circuit. So what you can do is you can convert the displacement to the voltage. Okay, so that's what. So transducer, what is a general definition of a transducer? It converts one form of energy to another form of energy. Okay, why we need to convert one form of energy to another form of energy, Babu? Okay, for example, you see this, you see this circuit. Okay, so basically I want to have a temperature. For example, I want to measure a temperature. Okay, so how can I directly take a temperature signal, right? It's not temperature signal and can I use directly a temperature signal and do processing? It's not possible, right? So what I want to do, first of all, I need to convert this temperature signal to some voltage. okay, using a sensor. That is done by the sensor. Okay, then what I can do, this voltage, whatever the voltage I got, is proportional to the temperature, right? That's what we have seen, right? In that interfacing, we get a voltage corresponding to the temperature. Now what I can, generally I get analog voltage, right? Analog voltage. Now what I can do, I can convert this voltage to digital voltage with the help of ADC. Okay, I get the digital voltage. Then what I can do, I can read this digital voltage, whatever I got inside a processor, or microprocessor or microcontroller. Okay, microprocessor or microcontroller. Okay, so I can do the processing, like or not. So if I have it directly, I cannot directly read the temperature to microprocessor, right? Definitely, if you want to process using a processor, okay, processor or a microcontroller, what we need to do, we need to convert these physical parameters. Okay, this input signal, these are the physical parameters, like we can have a temperature, or we may have a pressure, or a water level, flow level, okay, or acceleration, okay, or stress, strain, okay, whatever the physical quantity, okay. So we need to convert that first to the what, voltage. Okay, first that you need to convert that to the, okay, voltage. Then only you can have that voltage, you can read that inside the processor. In the sense, you need to convert to digital voltage, okay, so that you can read inside the processor, okay, and you can do the processing, okay. And you can, after processing, for example, you may read the temperature sensor. If the temperature is not enough, you need to turn on the heater. The turning on the heater, who will turn on the heater? Okay, that is, so okay, processor will take decision to turn on the heater, of course, processor will take that decision, but actually what is the circuit behind it? So actuator, right or not? So now you see, this is what a, so sensor also what it is doing. So in this case, sensor is a transducer, okay. So generally what you call in case of IoT, so this is regarding the IoT, okay. In IoT you call sensor plus, okay, sensor plus processor, okay, that is a transducer. Also the processor plus actuator, okay, that is also a transducer, okay. So basically this entire thing, whatever is there, this entire thing I call a embedded system, okay, where embedded system, okay, where I have a processor, okay, I have a sensor, I have an actuator. All these things is together called a embedded system, okay. That's why in case of, okay, that's why in case of IoT we talk about the embedded systems, okay. So this is what the basic understanding of what is a transducer, what is a sensor, okay. Definitely transducer is a circuit, okay, it's a device or a system which converts one form of energy to another form, okay. If you take a sensor plus processor, okay, so that thing is called a transducer. Also the processor plus actuator, okay, that is also called a transducer, okay. See, just in the previous class I told adding computational intelligence. What is meant by adding computational intelligence? Adding computational intelligence is nothing but what is meant by adding computational intelligence? Adding computational intelligence is nothing but you need to write a software in this, right or not? You need to write a software code in this, okay. That's what we have written, right, in the last class. What we have written in the last class, Arduino code, right? This processor we are using Arduino in the last class, okay. So in this Arduino we have written some control code, some software code. What that software code is doing, it is just, so before that we have interfaced the sensor to the processor, right? We have interfaced the temperature sensor to the processor, okay. So temperature sensor, what that is doing, it is reading the converting the temperature to the voltage and giving to the processor. What processor is doing, processor is reading that voltage, okay, and do some computations, okay, and that computation is displayed in the COM port, in the serial port. That's what we are doing, right, in the last class. So same thing I'm here also I'm explaining. So here I'm generalizing that part, okay. So the adding computational intelligence is nothing but we have a processor. In that processor, okay, for that processor there are various sensors, various actuators are interfaced to that processor, okay. So inside the processor there is some software running. That software is an intelligent agent here. That software acts as an intelligent, okay, so that is taking the decisions. So it is reading the sensor value, it is actuating that based on the algorithms written inside the processor. Okay, so basically that's what. Okay, so that's what. Okay, another important thing is, okay, another important point I want to convey here is, okay, just see here. So mostly what we'll be doing in IoT, in case of an IoT, whenever I call a sensor, okay, so sensor, okay, we have this all the circuit, okay, we have the input parameter, okay, which needs to be sensed, okay. So before giving to the processor, okay, here I'm not seeing, but before giving to the processor, we'll be having some signal conditioning, okay, we'll do some signal conditioning, okay. So signal conditioning is like the signal may not be perfect, so we need to apply some signal conditioning like amplification, okay, amplification, okay, filtering, order, okay. After doing the signal conditioning, we'll apply this to ADC, analog to digital converter, then we'll apply this to the processor, okay, then we'll apply to the processor. See, definitely in many cases, what we are doing, we are converting this input parameter to the electrical signal, okay. So electrical signal is nothing but, okay, mostly we are interested in the output of a sensor, okay, as a electrical signal. Electrical signal is nothing but, okay, voltage or current, okay. If you can able to convert this input parameter like temperature, pressure, acceleration, water level, flow level, all these things we are converting into voltage, electrical signal. What is the advantage of not? So why can't we connect to, why can't we take a mechanical signal, or why can't we take some pneumatic signal? Why only we are interested to convert to electrical signal is, the advantage is one thing is, we can, if it is electrical signal, then only I can read, I can have this software, right? Then only I can use the processor, I can use the software to process that signal, right or not? If you can have a mechanical signal or some other signal, I cannot use a processor. So that is the advantage. One thing is, if you can convert to electrical signal, okay, the physical form into electrical signal, the advantage I get is, what is the advantage I get? I can able to process it with the help of a processor or microcontroller. Then thing is, if it is electrical signal, it is easy to communicate, okay. It is very easy to communicate. The communication also will becomes easier, okay. So also I can apply the signal conditioning. So that's also one more advantage, right? So I can able to, if I convert this to electrical signal, the main advantage is I can able to process it with the help of a processor. I can able to communicate it, okay, easily I can communicate, right? And definitely in IoT, what is the situation? We need to communicate, right? So if I have this processor, I can have some Bluetooth module, or I can have directly Wi-Fi module, okay. With the help of this, I can communicate to some other, maybe gateway or cloud, whatever it may be, okay. So that's what we are interested in, converting the physical parameter to electrical signal, okay. So see here, this is the transducer definition. This is the general definition. Converts a signal from one physical form to another physical form. This physical form may be anything. Thermal, for example, temperature is a thermal, electric, voltage, current. Mechanical, displacement, linear displacement, whatever it may be. Magnetic is right, magnetic flux density, magnetic field intensity, magnetic flux density, magnetic field intensity, magnetic moment, like that. Many parameters are there, magnetic parameters, okay. Belongs to the magnetic field, okay. Like you can have a chemical, okay, you can have a chemicals, so chemical, like different chemicals, or optical, okay. So these are all the physical forms. So definitely in case of IoT, we convert all these physical forms to the electrical signals, maybe thermal to electrical, okay. Maybe electrical input may be there, electric to electrical, like that. Mechanical to electrical, okay, that voltage. Magnetic to electrical, chemical to electrical, like that, okay. You see this microphone. So microphone is one transducer which converts sounds, acoustic signal, to the electrical signal, okay. And speaker, okay, speaker I can call, okay, it converts, it's a transducer, it converts electrical signal to that sound, acoustic signal, like that. Antenna, right, antenna converts electromagnetic energy to into the electricity, like right. So generally electromagnetic energy in the form of E and H, right? So it is converted to VI, voltage current form, with the help of antenna, right? So like that, strain gauge converts the strain to electrical signal. Okay, so okay, Babu. So to just see, you just see the strain gauge. Okay, basically how, see, you may get it out, sir. How this is happening, sir? How this is, see how this happens? Like why? See, okay, it happens. So sensor is there. So sensor, based on the sensor, you are telling that okay, temperature is converted to, okay, temperature is converted to voltage. Okay, or whatever the pressure is converted to voltage. Something you are telling, sir. But how this is happening, sir? Is it really possible to have such? So definitely it is possible. Why means, for example, you take a strain gauge. Okay, so strain gauge, the point to the why, how this is converted is, what is, so what is a strain gauge? So this strain, for example, this is a strain gauge. It is made up of some resistive material. Okay, so it is made up of some, okay, metal. So many strain gauges are there. For example, you may think that it is some metal. Okay, so which is having some resistance. Okay, so which is having some resistance. Okay, so what is resistance? You know that what is resistance? R is equals to rho L by A, right? So where rho is the resistivity, L is the length, okay, A is the area, right? So L is the length, A is the area, and rho is the resistivity. You know this is the resistance. Now what happens if I apply stress? Okay, if I apply stress is nothing but force per area. Stress is nothing but like force. If I hit this with the help of hammer, something, that is a stress. So because of that stress, it undergoes a strain. Okay, this material, whatever the material, it undergoes a strain. What is a strain? So generally actual length is L. So now the length will vary. Actual area may be A. So area will vary. Okay, actual resistivity may be rho. So rho will vary. This change in length by actual length is called strain. This is what the strain. Okay, now what is happening? So because of this stress, if I apply the stress to the strain gauge, so because of the stress, resistivity varying, okay, generally we call this piezo resistive effect. Area is varying, length is varying. Because of all these parameters are varying, resistance is varying, right? Resistance is varying. Now you can say that, sir, stress, because of the variation of the stress, if I apply the force to this material, resistance is varying. Now what I do? I put this strain gauge in a Wheatstone bridge. Okay, for example, this is the strain gauge. I put this strain gauge in a Wheatstone bridge. You know what is Wheatstone bridge, right? So this is a Wheatstone's bridge. Okay, so generally what is this principle of the bridge? So generally for example, this is R1, this is R2, so R3, R4. So generally without any stress, so here I'm applying the stress. So without applying stress, this bridge is in balanced condition. So balanced condition is, there is, so here I'm take, for example, here I take the output voltage. Okay, so the bridge is in balanced condition without the stress. Okay, so if I apply the stress, so in balanced condition Vout is 0. Okay, if I apply the stress, okay, if I apply the stress, because of that resistance varies. Because of the resistance varies, bridge will become unbalanced. So I get a voltage, some voltage I'll get. Okay, maybe some 3 millivolts, whatever it may be, based on the stress applied. So now I get a stress, whatever the stress, this is a physical parameter I get in the form of voltage. So definitely behind every sensor like this, so this is behind the strain gauge. Okay, this is behind the strain gauge, right? This is the principle behind the strain gauge. Like that, okay, behind the temperature sensor, you take a thermistor or thermocouple or thermopile, or you take any other sensor, like you take any piezoelectric sensor or Hall effect sensor. Okay, or you take any kind of sensor. So you take any kind of sensor. Okay, there is some principle behind it. Okay, based on the construction of the sensor. Okay, based on some effects, maybe different effects are there. Okay, so because of some effect, because of that effects, the sensor is working. Okay, using that effect, the sensor is able to transform that physical quantity into the electrical signal. Okay, so that's what, right? It's not like you give this, it's, so there is some principle is there, right? Anyway, in IoT point of view, no need to know all those. Okay, so in the case of IoT point of view, no need to know all this, all such a principles. Okay, just what you need to know. Okay, now you ask, sir, okay sir, sensor is there, I want to, okay, we'll see that, just we'll continue this presentation. Okay, So this is what, right? I'm okay. Sensor, the characteristic of any device or material to detect the presence of a particular physical quantity. Okay. So the output of a sensor is a signal which is converted to a human readable form. Okay. Which is operating. So temperature sensor, for example, will sense the changes in the temperature of the environment in which it is deployed. Okay. So human readable forms in the sense, just now I told, right? So changes in the current characteristics, changes in the voltage characteristics, changes in the resistance, changes in the capacitance, changes in the impedance. So just now I told what I told. So strain gauge principle. Strain gauge is nothing but R is equals to rho L by A. So because of the stress, this resistivity varies, length varies, area varies, R varies. So change in the resistance. Like that, there may be having some sensor which operates the capacitive principles. For example, epsilon A by D, you know, capacitance, right? So because of some external displacement, distance between the, so what is this? Epsilon is nothing but permittivity, A is nothing but area of the plates, overlapped area between the plates, D is nothing but distance between the plates. You know, right? Parallel plate capacitor. This is a parallel plate capacitor, right? So this capacitor, what is the effect here? So maybe because of some external parameter, because of the displacement, distance between the plate varies. So if distance between the plates varies, definitely capacitance varies. Or maybe because of some external factor, area between the plates varies. Because of that, like that, right? Or there may be some something based on the inductive. Okay, so based on the inductance. Okay, inductance, I think mu A by, okay, L. Okay, mu A by I is equals to mu A by L. Okay, some expressions are there, right, based on the inductance. Okay, so inductance definitely depends upon the permeability. So all these parameters. So because of this parameter varying, inductance is varying. It's like that, right? So okay, Babu. So this is what, right, we are trying to okay, this is what the sensor principles. Okay, so perform some function of input by sensing or feeling the physical changes in characteristics of the system response. Okay, so these are the, so you see, this is the normal sensors used in IoT. So temperature sensor DH22. Okay, so this is some okay, which has both temperature and humidity. Okay, so inside such a sensor, that's what I'm telling, what it has. So suppose this is a temperature and humidity sensor. So inside such a sensor, what it has is, okay, it has all this okay, it has a okay, sensing mechanism. Also it has a signal conditioning. Okay, signal conditioning. Also it has a ADC. So finally this digital signal it will give to, okay, some sensors may only, so this is the digital sensor. For example, you take analog sensor. Analog sensor may only have this sensing. Okay, only sensing part is there. So now what you need to do for this external for this sensor, you need to add some external signal conditioning. Maybe you need to convert, you need to amplify, filter, all these things you need to do externally. Okay, externally you need to add, this is the sensor for this externally you need to add all these things, maybe, right? So this is a PIR sensor. Okay, this is a gas sensors. Okay, ultrasonic sensors, CMOS camera, so fire detector sensor, you can see these sensors, right? So okay, Babu. So just to see this is okay, just examples. Okay, so this is a piezoelectric crystal. Okay, just converting the mechanical to electrical form. So piezoelectric crystal means if I apply stress, okay, so because of that I'll get a voltage. Okay, that is a piezoelectric effect. Okay, like that piezoelectric crystal, you can have a electrical to mechanical. So like you have a vibration in phone, right? Phone will vibrate. Okay, so that is also based on some sensing effect. Okay, so okay, this is another example. You see this microphone, right? So whatever you speak, whenever you speak, okay, so whenever you speak, okay, so this is a diaphragm, this is a ribbon diaphragm. Okay, so whenever you speak, this will, okay, this will disturb. Based on the disturbance, you will get this corresponding voltage. Okay, converted, your acoustics are converted to the electrical form. Okay, so okay, Babu. So this is about okay, this is about the sensors. Okay, so finally, okay, before going to this, just see what, suppose I want to Okay, you have seen some sensor, you have decided that okay, I need to use some sensor in my project. Okay, for that what you need to know, okay, if you want to use this temperature sensor, there are many temperature sensors are available. Corresponding to every sensor there is one data sheet is there. Okay, you need to go to, you can download these data sheets. Okay, and okay, for example you see this, so this is a LM35 sensor. Okay, this is one of the temperature sensor available in the market, which is supplied by the Texas Instruments, okay, company. So if you observe this sensor, okay, so you already know, right? So but they give this all these characteristics. Okay, so all these characteristics they will give, right? So in order to understand such a data sheet, okay, you need to see the data sheet and you need to maybe design some circuit. Okay, for example, see, you want to use this sensor, okay, like LM35, they give this much supply voltage you should give, so output voltage this many volts you will get. Okay, so based on that you should be able to design your software, right? It's not that like that you connect the sensor, okay, you'll get whatever you require. Not like that, you need to write some software code. For that code you should be able to do something, some design, right or not? For doing such design you should be able to understand this data sheets. Okay, you need to understand, for example you want to design a PCB, your own PCB, you should know this you know such a layouts, okay, layouts of the sensor. Okay, how many pins I need to allocate, okay, what is the pin description of the sensor, all these things you should know, right or not? Still you want to do some research also, you should be able to know all these characteristics. Okay, you see here accuracy, non-linearity, gain, load regulation, so these are the different characteristics of the sensor. Okay, you should be able to understand, so in what conditions it's able to run, so all these things, okay, at least few things you should understand in this. Okay, they have also given some graphs, okay, so of the sensor. So after all this such a test only they will okay, they will give the sensor outside, right? Outside they'll release such a sensor. So layout, see here layout, you want to design a PCB for the sensor, you need to use this sensor in the PCB, they definitely should know the idea about the layout of the sensor, right? All this information is available in the data sheet, right? So now with this information, okay, again we'll continue. So definitely these sensors have certain characteristics, right or not? So these characteristics are divided into two types, static and dynamic characteristics. Okay, what is static characteristics, what is dynamic characteristics? Okay, uh, okay Babu, so just know, for example this is a sensor, okay, this is a sensor, this is the input to the sensor, okay, this is the output to the sensor, right or not? So if you give input to a sensor, for example if you give input to a sensor, you should get a output automatically, right? If you see this not in the context of some second order system, for example some second order system, okay, you might have noticed it such a graph. If you give some, okay, some step input, okay, what will get output? You should get the step output, right? But what you get, you will not get step output directly, right? You get such a output, okay, you get such a output, right or not? So what is this? Okay, you get such a output, but this is the desired output. Okay, but you are not getting desired output automatically, you are getting some time, right? You are taking some time, right or not, to get a desired output. So this initial output which you get, this is called the transient response, right? This is called the transient response. Okay, so this final steady state output, so this is called the steady state response, right? So this is called the steady state response. Okay, so steady state, this you might have studied in signals and systems or control system subject. Okay, whatever it may be, the point here is, if you investigate why you are getting such delay, this much delay, why you are getting, you need to investigate that and you need to estimate. Okay, you need to come up with solution. So if you want to investigate, okay, if you want to find the response, okay, what are the characteristics of your sensor in the transient response, right? In the transient response. Okay, so these are the dynamic characteristics. Okay, so these are the dynamic characteristics. Okay, if you want to estimate the characteristics in the steady state, these are the static characteristics. Why static? Means not changing, output is steady, it's not changing. But in case of dynamic, Okay, output is changing. Okay, so based on that, your sensor, if you consider sensor as a system, sensor has static characteristics and dynamic characteristics. Okay, so static characteristics, how the output of a sensor change in the response to an input change. Dynamic characteristics, the properties of the system transient response to an input, initial response. That's the dynamic characteristics. So based on, so no need to go. So just you need to know all these things. So accuracy. So accuracy, what is accuracy? It represents the correctness of the output. Okay, like if you want to have measure the actual environment is 30 degrees. So whether you are exactly getting 30 degrees with the help of sensor. So that thing you need to know. That is that tells about the accuracy. Okay. Suppose if your actual environment is 30 degrees, your sensor is sensing 29 degrees. It's not accurate, right? So like that range, what is the lowest value? What is the highest value? Like our sensor may detect from minus 30 to 30 degrees centigrade to 150 degrees centigrade. This is the range of the sensor, right? Like that you should have a resolution. What is the smallest change that sensor is capable of? Like suppose now temperature is 30 degrees centigrade. Okay, like if your sensor resolution is 1, so next output will be only when it is 31 degrees centigrade. So from 30 degrees centigrade to 31 degrees centigrade, it will give the same output. It's like that. So if you have a less resolution, it's a okay, so higher resolution means more precision. Okay, so that's about the resolution. This provides the smallest change in the input that sensor is capable of sensing. Like error. Okay, so error, what is the standard value? What is the difference between the standard value and the value produced by the sensor? Okay, so these are all the characteristics you should be able to understand. So where, so just now I told this, all these characteristics will be given in the data sheet. Okay, like sensitivity. Okay, change in the output by input. Okay, linearity, drift, repeatability. So okay, this is some high level discussion, but just know that okay, your sensor have this okay, for example, you see this drift. What is this drift? The drift is, so linearity. Linearity is nothing but input output relation. So input output relation should be linear. Okay, so input to the sensor and output to the sensor, okay, must be linear. Okay, so this is what the desired characteristic of a sensor. If it is non-linear, how to estimate, how to calibration becomes difficult. Okay, so whatever it may be, you just see this drift. The drift is nothing but the difference in the measurements of the sensor from a specific reading when kept at that value for a long period of time. Okay, like for example, if you want to measure 30 degrees centigrade, okay, suppose if it is 30 degrees centigrade, if you measure today or tomorrow or day after tomorrow, it must be 30 degrees centigrade, right or not? It should not change. So like that, so like that different characteristics of sensor are there. Okay, so like that you have a dynamic characteristics. So based on whether your system is zero order, okay, or first order or second order, you may have this dynamic characteristics. Okay, like for example, zero order system has a no delay. Okay, but first order system, second order system, it has some energy storage elements. Okay, zero order system means it has only resistances. First order, second order system will have the energy storage elements like L and C's. Okay, so okay, whatever it may be, just I want to give you some idea about what are the characteristics of sensor. Okay, try to note this. And finally, some classification. Okay, so passive sensor, active sensor, digital, analog, scalar, vector. Okay, Baba. Suppose what is active sensor? Active sensor is nothing but sensor does not utilize any external supply. Okay, so sensor by itself can generate the output without using any external power supply. But what is passive sensor? Passive sensor is something which have to use the compulsory external. So sensor have to use some supply. Okay, so sensor have to use some supply. Definitely right. In case of temperature sensor, what we did? So our temperature sensor is passive or active? It's a passive. Why? Our temperature sensor has three pins, right? So what are these 3 pins? One pin is output. Okay, one pin is the output, V out. Okay, so another pin is the voltage, right? This pin we are connecting to the 5 volts, right? This pin we are connecting to the ground. So we are giving supply to the sensor. Without giving supply, the sensor won't work. So this is a passive sensor. So there are some sensors which are active sensors. So without having supply, it can give the output. Okay, so like that we can have analog and digital. Like if the output is analog, okay, continuous value, this is a V out, or we can have a digital signal. Okay, like that we can have, based on the output, we can have analog output or digital output. Or scalar and vector. What is scalar? Scalar has only magnitude. associated with it. So if sensor output is depend only magnitude, okay, so but vector means magnitude and direction both are important. That sensor, okay, sensor output depends upon the magnitude. We need to consider both magnitude and direction of the sensor. So that's the same thing, right? Passive sensor cannot independently sense the input, right? It should have some external supply. Active sensor independently sense the input, right, without using any external supply. Okay, so analog sensor, the response of the output of the sensor is continuous function. Okay, digital is binary, right? Binary sensor. Okay, so scalar vector detects the input parameter only based on its magnitude. Okay, like vector sensor depends upon the magnitude and direction. Okay, Babu. So this is what actuator formal definition. So far we have covered the sensor definition, sensor characteristics, as well as sensor classification. Now we go for actuator. Okay, so actuator, what is actuator? Actuator is a system that deals with the control action required, right or not? Control action is turning on the motor, turning on the relay, okay, like turning on the valve, all these things. Okay, so what is the formal definition for this? Okay, so actuator is a part of the system that deals with the control action required. So this is the basic basic block diagram of an actuator. Okay, so this signal, basically this signal, whatever the signal is there, this is given by the microcontroller. Okay, so the signal is given by the microcontroller. Okay, so it uses some external energy. Okay, based on that it will convert this signal to the motion or force. Okay, motion or force, that's what, right? In case of motor, it is converting to whatever the signal the microcontroller will do. Based on that it will turn on that motor.
Shabari sir, are you speaking? We cannot hear you.
Oh, I think someone muted me, ma'am.
Yes sir, just it happened just now.
Ma'am?
ఇప్పుడే అలా జరిగింది సార్ 2 minutes అవుతుంది అంతే.
Okay, ma'am.
Okay.
Okay, so okay, I think you are frustrating with this. Actually, the point is every time we cannot have some practical session, right? So I can understand, but okay, whatever it may be, you understand or not, at least you try to understand this thing. Okay, now our first agenda has been finished in the today's in this presentation. Our first agenda is like we told that, okay, in case of IoT, okay, so definitely we need to use sensors and actuators. Okay, these sensors and actuators, what we need to do, we need to connect these sensors and actuator to a processor or microcontroller, right or not? We need to connect this to a processor or microcontroller. Now these sensors, actuators, and this processor or microcontroller together, all this thing is called an embedded system. Okay, now okay, it's time to study. We put a, now what we do now, what we do now is we have a system, right? So in that system, okay, we have a system. Okay, so now we have a system. Okay, so to this system, okay, we have, okay, so in this system, what is, if you take this system, what is happening, the system has a microcontroller. Okay, to this microcontroller we have sensors. Okay, to this also we have actuators. Okay, also not only actuators, we may have some network. Okay, network connection. Okay, so together all these things, we call as a embedded system. Okay, together we call as a embedded system. Okay, now so this is what we can think of a node in IoT. Okay, so node in IoT means, so node in IoT, so this node in IoT, right? So IoT node is nothing but it has a sensor. Okay, it has an actuator. Okay, and sensor and actuator, they cannot use standalone, right? So definitely to use this sensor and actuator, definitely we should have a microcontroller. Okay, we should have a microcontroller. Then in this microcontroller we are writing some software. Okay, this software is adding computational intelligence. Okay, okay, where the sensor is deploying. So maybe we may keep the sensor in a fridge. Okay, and to that sensor we may add a microcontroller. Okay, we may keep this sensor in a table. Okay, whatever you want to make a thing. Okay, like that. So based on that you may have, okay, you may have a sensor, microcontroller and actuator and network connectivity. So now I am calling this as an embedded system. Okay, that is one node in an IoT. Okay, so embedded system example. Okay, all your bikes have such a system. Okay, so bike have such a system. Bike has what? Okay, it will show that okay, in bike's inbuilt computer. So your bike will show this speed and distance, right? It will show some measurement, it will show, right, speed and distance. Nowadays digital. Okay, it will show your speed. Okay, how many kilometer per hour you are traveling. Okay, and how much distance you are moving, your bike is traveled so far from the beginning. So that information, digital information you are getting, right? So behind that there is one embedded system is there. What is happening, you know? So based on the wheel rotation, it is okay, there is some sensor is there that is converting that data. And okay, it has some user inputs, like a user switch. Okay, and this CPU. Okay, whatever the microcontroller, this is what microcontroller. Okay, so this is what microcontroller. Okay, so microcontroller, it has a memory. Okay, so this is a SRAM memory, static RAM memory. This is a flash memory. Okay, also it has a outputs, like it has some power management. Okay, so in order to optimize the power, it has some power management unit. Okay, also it is displaying in the LCD, right? This is the output. Okay, now this is one of the embedded system. Okay, so this is one of the best example of embedded system. So to deploy such an embedded system. Okay, for example, in case of a bike. Okay, what is the requirements you have if you want to deploy such a system in a bike? So definitely you are deploying such a system in a bike. Your system should be have less size, low cost. Okay, if you your bike cost is 50,000, for example. Okay, suppose if the system costs 10,000, it's useless, right? So you are using as an integral part in your bike. This is not related to bike, right? So definitely it should be some 300 rupees, for example. Then you can use that in a bike. If it is a 10,000 rupees, you cannot use that in a bike, right? It's like that. So it should have less weight, right? So definitely it is not related to the bike operation. It is just displaying a speed and it is giving you some comfort. Okay, so in such a scenario, this should not occupy the whole weight, right? It should be less weight, right? Also, it should consume the low power. Okay, that's why we use some power management. Okay, some power management in the sense when this is, for example, you can do power management like this. When you are not riding a bike, the system have to shut down, right? Or you shut down automatically. You should not do, right? It will automatically shut down, right? Whenever you turn off the power of your bike, this system will automatically shut down. Okay, so that power management system will be there. It will have some automatic shutdown. Okay, so to implement such a system, we require a simple 8-bit. Okay, 8-bit and 10 MIPS. So MIPS stands for million instructions per second. Okay, so million instructions per second. So such a small CPU is enough. 8-bit CPU is enough. I don't require any higher multi-core processor or a big processor. to implement such a system. Okay, for example, you take another example. Okay, so so this is somewhat complex here. So maybe some motor control unit is there in this. Okay, the functions of a system are, okay, so this system needs to be connected to a network. This system needs to read the sensor values, maybe some sensor values, okay, some speed, all these things. Okay, also this system needs to communicate with others, okay, other systems, like maybe it needs to communicate it with a gateway, okay, with a gateway. Okay, so in such a scenario, 8-bit CPU is not sufficient. Okay, so see here previously, the system no need to communicate with any network. It's not any IoT device, right? Just it is having some output. Just it is sensing some data and displaying in the LCD. That's it, right? It is estimating what is that speed. Okay, what is the speed of a bike and how many kilometers you have traveled. That information it is storing in the LCD. It is showing in the LCD. It is not connecting to any network. For that, 8-bit is sufficient, right or not? But in this case, you are connecting to the network, you are operating the motor. Okay, so such a CPU is generally preferred in a IoT. Okay, so in such an embedded system, you should use 8-bit is not sufficient. You should go for 32-bit process. Okay, so you should go for 32-bit. Okay, 32-bit process. Okay, Babu. So I'm talking 8-bit, 32-bit. Okay, so 8-bit, 32-bit. What is this 8-bit, 32-bit? Okay, I think yesterday they have told about this microcontroller. Okay, introduction. Just I'll tell what is this 8-bit. Okay, so okay, what is meant by 8-bit, Babu? I'm telling 8-bit. Okay, I'm telling 32-bit. Okay, so this is nothing but, okay, so internal your processor, okay, your microcontroller. Okay, if it is a 8-bit, okay, so it can directly operate on the 8-bit data. Okay, if it is a 32-bit, it can operate on the 32-bit data. What do you mean by that? Using 8-bit, if it is a 8-bit processor, it can only do 8-bit. For example, you take addition, it can only do 8-bit plus 8-bit. Okay, 8-bit plus 8-bit. If I want to do 32-bit, okay, if I want to do 32-bit addition in the 8-bit processor, if I want to do 32-bit plus 32-bit, okay, in the 8-bit processor, how it will do? So it will, okay, for example, 32-bit can be saved like this. For example, A, B, B, C, C, D, D. Okay, this is the 8-bit, 16-bit, 24, 32 bits like that. Okay, EE. So this is hexadecimal, right? You know, you can relate. So hexadecimal representation, E, F, G, H. So what it will do, 8-bit will do, it will take these 8 bits, undo. After completing, again it will take, it will do. After completing, again it will take, it will do. After completing, again it will take, it will do. Right? So for example, if I tell that it takes some 1 millisecond, okay, one operation. So it takes again 1 millisecond, again 1 millisecond, again 1 millisecond. Like, so it requires 4 milliseconds to do 32-bit addition. But what about a 32-bit? So 32-bit has hardware sufficient for doing 32-bit. Only 1 millisecond it can do this 32-bit. That's what. That's the difference between 8-bit and 32-bit. Okay. So, okay, Babu. So with this information, just see this. Okay. So suppose simple example I'm giving here. So we have a pressure here. Okay. Pressure is a parameter which we need to sense. This is the parameter. Okay. So we use a pressure sensor. Okay. So corresponding to the pressure. Okay. This is the characteristics. Sensor. Okay. Input pressure versus output voltage. Okay. Now what it is doing? It's some linear. Okay. It is showing some linear characteristics. Right. So based on this, it will give the corresponding voltage. Whatever the pressure is there, corresponding to that pressure. For example, if it is 150, corresponding to the 150, it gives that 3 volts. It gives the voltage. Okay. That analog voltage is converted to the digital voltage. Okay. Digital voltage. See here. So digital means we'll get some bit pattern. Okay. We'll get some bit pattern. So this digital code can be read by the microcontroller. Okay. Read by the microcontroller. Right. This microcontroller we can either communicate. In case of IoT, what we do, we just, in case of normal thing, we can display. Okay, we can have a display and we can know what is the pressure. But in IoT, what we do, we communicate this to the gateway. Okay, for example, so using wireless network, we can able to communicate maybe with Bluetooth. Okay, whatever it may be. Okay, this will communicate. Okay, So here what is this application is, okay, read the ADC value. Okay, what this microcontroller, what it is doing is, see here, it will read that ADC code. Okay, so calculate the sensor voltage from the ADC code, convert the sensor voltage into pressure, calculate the depth from the water pressure. So in the last class what we did, we have read that voltage, temperature value. By using some calculations, we have converted the temperature value to the exact temperature value, right? Same thing it's also doing. It reads that sensor voltage from the ADC, convert that sensor voltage to the pressure. Based on the pressure, we are calculating the depth. Okay, what is the depth? Depth information. So the depth information we can communicate. We can either communicate or we can display. Okay, so this is what happening, right? This is what we have practically seen in the last class in Arduino case. So there the temperature we are used. So anyway, that is not it. Directly Arduino has an analog input, right? Arduino has analog input. So directly we are reading that. So we are not using any ADC there. We are directly using the analog input and we are reading that value, and we are converting that value based on that calculations. We converted that value to the exact temperature value. In that case, temperature value. And okay, we are displaying in the COM port, like LCD. Instead of LCD, we have displayed that in the COM port. Okay, now in case of IoT, what you can do, you can transfer that to the gateway. Okay, Babu. So this is what I'm calling it as an embedded system. So this entire thing is an embedded system. Okay, this entire thing is an embedded system. Okay, so definitely embedded system is an integral part of an IoT. So embedded system is responsible. Embedded system will have a sensor. Embedded system will have a microcontroller. Embedded system will have a actuators. So this embedded system will act a computational, okay, computational intelligence to your thing, as well as a network connectivity. Okay, so network connectivity. Okay, Babu. So final one point I want to tell here, and I want to wind up the class. Just okay, 1 minute. The point which I want to tell is, just listen that point and try to, we'll wind up that today's class. Okay, so okay, so what I'm telling is, I have an embedded system. Okay, Babu, I have an embedded system. So this embedded system has a sensors, right? It has a sensors. Okay, it has a controller. Now what I can do is, in this system only I can have a Wi-Fi. If I have a Wi-Fi, for example, I can communicate this to a cloud. Okay, I can come, like previously I am sensing the pressure. That pressure value, from pressure value I am estimating the depth. The depth value I can directly communicate to the cloud. If I have a Wi-Fi such a, okay, if also what I can do is, I have an embedded system. Okay, I can have a sensor. Okay, sensor data, for example pressure value. Instead of Wi-Fi, I can have some Bluetooth kind of thing, Bluetooth or Zigbee kind of thing. Okay, so this, using this we can, so this Wi-Fi has TCP/IP, it can directly connect to the cloud, right? But in case of Bluetooth or Zigbee, what we need to do, it cannot have capability to communicate with the cloud. It has some distance, right? It can communicate with certain range only. So what we can do is, using Bluetooth, I can communicate this to a Raspberry Pi kind of thing, like a gateway. Okay, gateway, for example, maybe a Raspberry Pi. Okay, Raspberry Pi. So this has a Wi-Fi. Okay, it can communicate to the cloud. Okay, so like this also we have embedded systems. Directly embedded system can connect to a, like IoT node can connect to a cloud. Or what I can do, I can have a system which has a Bluetooth local connectivity. Using this I can connect to a gateway. Okay, and I can connect to a cloud. Okay, in the case of gateway, people will be using mostly, okay, mobile phone. You can use your smart mobile phone. Okay, so that whatever generally okay, your gadgets will do like that, right? You have smart gadgets, right? So smart gadgets have a Bluetooth. That smart gadget, maybe smartwatch, that smartwatch is connected to your mobile phone. Your mobile phone is connected to the cloud. Okay, it's like that. Okay, so now with this point, still there are few points are there, but anyway, time up. So this is what I want to give from embedded side, embedded system point of view. So today you understand what is sensor, what is actuator, what is processor or microcontroller, what is embedded system basically. Anyway, processor